right? So the second part of this problem, we want to actually figure out how long it's going to take our ball to hit the ground again, right? As soon as it leaves the person's hand, we know it's going to go all the way up, and then it's going to fall all the way back down again, okay? Right? And the nice thing about these up and down scenarios is that it's essentially a mirror image, right? The way up is a mirror image of the way back down again. Okay. In the previous problem, we figured out exactly how high up this is, right? The overall height was 31.25 meters. Okay. And as we're going up, we know that our ball is going to slow down until it reaches a velocity of 0 meters per second when it starts to fall back down again. Okay. We also know that on the way up, it was experiencing an acceleration of negative 10 meters per second, right? We're keeping this negative because we're assuming that up is positive, down is negative, and if our overall net force is in the negative direction, then that means our acceleration is in the negative direction too. But this acceleration is going to be the same no matter if we're going up or if we're falling back down. Okay, so even on the descent, the acceleration is still negative 10 meters per second per second. Okay. So if we want to figure out how long it takes the ball to hit the ground, again, it's nice because we can assume a lot of these truths, that the acceleration is always constant, that the distance up is the same as the distance down. And in fact, because we are landing in the exact same spot, right, from where we started, our overall change in position from start to finish, think about it, the overall change in position from start to finish, the overall change in height is 0. The ball ends in the exact same spot that it began. Okay, so if we were to think about this trip all the way up versus all the way back down again, okay, where we have an initial position of 0, we also have a final position of 0. Okay, if we have an initial velocity of 25 meters per second, we can actually make some assumptions about our final velocity, but I'm just going to leave it blank for now. Okay. We can also assume the overall acceleration is negative 10 meters per second per second. Okay. And we can talk about time as well. Okay. So throughout this problem, like I said, it's a mirror image of itself. Okay. If we're starting at 25 meters per second, we're experiencing this acceleration. Okay. And we're going to get to 0 at some point. In the previous problem, we figured out, actually pull it up right here, figured out all these details. The one thing we didn't solve for was time, okay? But if we could take some of our knowns here, I'm gonna actually go back to this first problem. If I wanna solve for time, I can use this formula right here. Okay, a really quick way. Final velocity was 0, acceleration is negative 10, solving for time, initial velocity is 25. Okay, when we break this down algebraically, we should get time is equal to 2.5 seconds. Okay, 2.5 seconds. That was the trip up. And I said it's a mirror image, right? If we are starting at 0 meters per second on the way back down, we have an acceleration of negative 10 meters per second, and we are falling the same height, okay, you'll find that the time to descent is also 2.5 seconds, which is kind of nifty, okay? So long story short, if it takes 2.5 seconds to get to the top, it's going to take an additional 2.5 seconds to fall back down again. Okay, so the overall time it takes would be 5 seconds, which is kind of nifty. How else could we look at this? Okay, let's say instead of looking at the mirror image of the time, okay, let's see based on these. I'm even going to cross this out. Let's say just based on these data, I wonder if we could figure out our final velocity. Right? We know the initial position, we know the final position. we know the initial velocity, we have our overall acceleration. We could figure out our final velocity without time. All right, so if we go to our kinematics equation, we're looking for final velocity. Final velocity, final velocity. Couldn't use that one. Okay, we don't want to use this one here because let's say we still don't know what time is. So let's not use that one. Can't use that one. We could figure out your final velocity using this formula because we have the initial velocity, we have the acceleration, and we have the overall change in position, right? Okay, so remember I said that we're going to start and end at the same spot. So our overall change in position is 0. We have our initial velocity, we have our acceleration. Let's use this problem here, or I'm sorry, this equation here to solve for our final speed. So let me rewrite that. Vf squared equals Vi squared plus 2a x of f minus x of I. Okay, let's plug her in. Final velocity, don't have it. Initial velocity, 25 meters per second. We are going to square that value. And then I know that my overall change in position is 0, right? So this whole thing's 0, which means that this whole thing is 0. So I can just get rid of that. Hey, look at this. Final velocity squared is equal to 25 squared. Well, this, okay, we'll just humor each other. Okay, let's say it's 625 is equal to Vf squared. Take the square root of both sides. Vf equals 25 meters per second. Okay, like I said, it's a mirror image. Our initial launch speed at this point is going to be the exact same as the speed in this direction. Okay, the one caveat though is that because now we are going in the negative direction, we should make this negative as well. Okay, so now that we've got these values, right, you could use any of your kinematic equations, except for the timeless one, to solve for t, to solve for time, and you'll find that it should give us 5 seconds. Okay, so there's a lot of things to kind of keep in mind here. The most important thing that I want you guys to recognize is that when you're talking about a parabolic motion like this, projectile motion, the way up is a mirror image of the way down. Whatever our starting speed is up is going to be our final speed down, just in the opposite direction. We also know at the highest point, the velocity is going to be 0. Okay, we know at every single point, doesn't matter where you are, the acceleration is always going to be minus 10 meters per second per second. Okay, so with these free fall problems, we don't always give you a lot of information, but if it's a free fall problem, you can assume quite a lot. Okay, so go ahead and try the rest of the kinematics 3 practice, and then we'll go over these tomorrow.